In one of the last lectures in this module, we already discussed different technologies that can be utilized to build star couplers. Here, it's just a reminder, I show here 3 different technologies utilizing Y branches, 1x2 splitters, utilizing tapered fusion couplers, and also utilizing 2x2 directional couplers. Now let us compare their performance in terms of what would be the loss for such a star coupler for each of the 3 methods, and then decide if we need to minimize the losses or what would be the preferred design. For Y branches, let's say that we communicate, let me choose a pen. Let's say we communicate from this port to this port. So the light will need to go this way through the coupler. And remember that ideal Y branch adds 3 dB loss. So one time we will experience 3 dB loss here. Second time we will experience 3 dB loss here. Then another Y branch here. And another 3 dB loss here. Total, it will be 12 decibel loss. As for second design, using tapered fiber here, I'm trying to use a marker, so using this design, it is done by twisting and then heating, melting the glass and pulling away apart the fibers. This way, in all output channels, signal is split equally. So meaning that if we start here, let me change to the pen. If we start here with 100% and then look to the output ports, each output port will bear 25%. So we use 3/4 of the signal. When we use 3/4 of the signal, think about it like that. You decrease signal level 2 times and then you decrease it another 2 times. Total, you decrease it 4 times, 2 and then another 2, right? So your final output power is 25%. But in terms of dB, it's easier to think you reduce it 2 times. You add 3 dB and then you use it another 2 times, another 3 dB. So total loss therefore is 6 dB, 3 dB plus 3 dB. Now the last case, let me make it laser pointer. The last case is using directional coupler, and let's say again we start, for example, here, and light will go, let's send it this way, does not matter. So it will go through the tap port of the of the first coupler, and then through a throughput port of the second coupler. We know that when we have ideal 3 dB couplers, output port will suffer 3 dB loss. So since signal goes through 2 directional couplers, total loss will be 3 dB plus 3 dB, it will be 6 dB. Now if we compare therefore the performance in 3 cases, we can see that tapered fiber fusion technique and using directional coupler will provide a better performance in terms of losses, 6 dB losses. And using Y branches, we will suffer serious losses. So maybe depends. If signal is weak already, maybe it is better to use either fused couplers or directional couplers. But again, it depends on whether your system can maintain that loss, and also what are the available components you can build your star coupler from. Let's consider one more example. Let us build a 4x4 star coupler utilizing 3 dB 1x2 Y branches. So transmitters and receivers are connected using LC connectors with 0.5 dB loss per connector and also by number of Y branches. As you can see here, total in the star coupler we will need to use 1, 2, 3, 4, 5, 6 1 by 2 Y branches. Now question, what is the total system loss for the signal to go from any transmitter to any receiver? For example, let us choose let me change to the pen, from transmitter 1 to receiver 2, for example. Signal will go through how many Y branches? So it will go through this Y branch and suffer 3 dB loss. It will then go through this Y branch, and then will go through this Y branch, another 3 dB loss, and then go through this Y branch, another 3 dB loss. And also it will go, let me change color, it will go through a number of connectors, because each Y branches are connected by connectors, and also station terminals are also connected to the network by using connectors. So we have one connector here, we have then one connector here between two Y branches, another connector here between two Y branches, and then another connector here between two Y branches, and then one connector to connect the fiber to the station. So total we have 5 connectors when light goes from terminal 1 to receiver 2, and it will go through 4 Y branches. Since for each connector the loss is 0.5 dB, and for each Y branch splitter the loss is 3 dB, total loss will be 0.5 times 5 for connectors, 2.5 dB total, and 4 times 3 dB for the splitters, total 12 dB, and the total loss the system will suffer is 14.5 dB. So to summarize, the star coupler we built using Y branches, 4x4 star coupler, will have 14.5 dB loss when we connect any input terminal to any output receiver. That is all for this tutorial.